I think there is a lot of promise there in terms of lowering the need for a high treatment burden for patients. There are some patients that have a low treatment burden. There are some patients that do well with less frequent monitoring, with less frequent treatment. And I think those patients may, ultimately, depending on what the therapy is, the durability, it's hard to say specifically because we don't have that long-term data yet. But I think those patients might, continue along their path of receiving treatments. But for patients with a high treatment burden, I think it's an amazing opportunity because it really lowers their reliance on the visits. It lowers their reliance on their caregivers, on their family members to come with them every month to the visit. So it really does change everything for our field in terms of taking care of the patients with a higher or medium treatment burden. But I think we'll know more as more data becomes available. It's exciting to have different routes of delivery. REGENXBIO specifically is exploring both subretinal and in-office suprachoroidal delivery. So it's exciting to have options there, which will also play a role in what patients receive it. So I think it's a really wonderful technology, and we're super lucky to be able to work with it and have many patients already receiving it in the context of clinical research.
Yeah, so there's several TKIs that are being evaluated in the retinal space. These TKIs work intracellularly. They are pan-VEGF inhibitors as opposed to the anti-VEGF-A agents that we currently have. They also inhibit PDGF. And so the thought is that through the pan-VEGF inhibition and also through inhibiting other mechanisms of action such as PDGF, that we may see results in patients that result in perhaps better anatomy, visual acuity, hopefully, and durability.
We're really lucky in retina right now to have 2 FDA-approved treatments for geographic atrophy. But one of the troubles that we've had in following patients with geographic atrophy is finding ways to measure how their disease progresses. We know that you can use imaging, fundus autofluorescence and OCT are really helpful, but when you actually look at functional endpoints, things like best corrected visual acuity, or how quickly a person reads or doesn't read, how well their vision is in normal light versus less light, it's been really hard to come up with functional endpoints. Microperimetry, which is what I was talking about today, potentially is a way to kind of bridge that gap. It is sort of like a visual field of the central macula. There's 68 points that are looked at. And what we're looking to see is how well it correlates with what we're seeing anatomically to what the patients tell us that they're experiencing. And the other studies have found that microperimetry seems to be the test that best correlates with the amount of damage that's actually occurring in the macula. So this was a big deal because this was the first time in a pre-specified endpoint that we showed that eyes that received pegcetacoplan monthly had better preservation of points on the microperimetry. Previously, we had shown that in a post-hoc analysis, those cells were protected, but post-hoc analyses are always questioned in terms of their scientific rigor, but a pre-specified endpoint is kind of a higher bar. And now that we've shown that, it really gives us great encouragement that the trend that we were seeing previously is actually borne out in the 36-month data. So it's really cool, really exciting stuff.
Sure. It's a 6-month data. It's a 1-year study. It's gene therapy. It's a single injection. You do one baseline injection of aflibercept a week before the gene therapy. You do a second injection of aflibercept 4 weeks after. Essentially because it takes, in general, between 6 and 10 weeks to get the expression of the gene therapy to make the retina actually produce the aflibercept and the interfering RNA. And then you just watch the patients. 77% of the patients in the high dose group, the 3E10 group, did not need any additional treatment over 24 weeks. And 93% only required 1 additional injection over the 24 weeks that we've been looking at so far. And the study's continuing. If they need additional treatment, we obviously give it to them. They're very straightforward criteria for anti-VEGF supplementation, which include vision and OCT thickness, and then we watch those patients.
So patients always want to have treatment that have greater durability without compromising on disease control. So having faricimab as an option in our clinic has been great. I've been using it as a first-line treatment for the patients because we're able to rapidly improve anatomy and control disease and extend those patients out to 3 or 4 months in most cases. One thing that's reflected in the RONEX data that's important, that it is the largest extension study done to date, and it had a retention rate of 82%, which means that patients actually did not drop out from this study because majority of them were on every 3 or 4 month dosing. So I think if we can decrease the treatment burden for our patients with DME, we will be able to have better retention and less dropout in future trials as well as in clinical practice.